Okay, so today we are going to continue our work with the difference quotient and our first principles strategy of being able to find the instantaneous rate of change for a function at a point. And we are going to use that to help us find the equations of tangent lines and normal lines to the curve. So first of all, we'll just do a quick definition of what tangent lines and normal lines are, even though I think at this point you've probably seen those definitions quite a bit. We'll do a warm-up question just like we would do on the boards if we were in class, and then we'll fill in our short notes to summarize. And there's just one practice question, it has a couple parts to it, page 33, number 11. And for each one of these, the question says just find the tangent line, but I want you to find both the tangent line and the normal lines for each question. Okay, so a quick recap before we begin. Tangent lines. If we have a curve, so let's just say that this black curve here is called f at x, then we know that the tangent line is a straight line that passes through a point on the function f at x and has the same slope as the function at that point. So if I choose this point right here and I want to draw my tangent line, it's going to touch it just at that point, and the slope of the function at that point is the same as the slope of the tangent line. And then we know from our work in vectors that normal lines are perpendicular to things. So the normal line in this example is going to be perpendicular to the tangent line. So if the tangent line has the same slope as the function at that point, then the normal line is going to have a perpendicular slope to the function at that point. And we know that if two slopes are perpendicular to each other, that they're also going to be negative reciprocals of each other. And that's how we can tell that they meet at 90 degrees. So based on those definitions, I would like you to take a minute and try this warm-up question. So we're going to start with a function f at x equals negative 2x squared plus 3x plus 1. And I want you to do three things with it. So first of all, I want you to determine a function that can be used to find the instantaneous rate of change at any point using first principles. So that's a recap of some of the work that we did last week. The second thing I want you to do is to determine the equation of the equation of the tangent line at that function at x equals 3. So if we draw a point at x equals 3, what would the equation of the tangent line be? And then also for C, determine the equation of the normal line at x equals 3 as well. So I would like you to pause the video, give these questions a try, and then on the next slide, I'll have my solutions. Okay, so here's what I came up with. So we start with the function f at x equals negative 2x squared plus 3x plus 1, and we want to find the instantaneous rate of change function. So we're going to use first principles to do that. So I know from our work last week when we talked about writing instantaneous rate of change as a limit of the difference quotient. So I've got limit as h approaches 0 of f at x plus h minus f at x over h. And what I'm going to do is I'm going to figure out what f at x plus h is, what f at x is, simplify it up, and see if there's a way that I can sub in h equals 0 into my function. So right now I can't do it because h is on the bottom of a fraction, and I can't sub in 0 on the bottom of a fraction. So what we want to do is we want to sub in our values and see if we can manipulate it so that we can actually sub in h equals 0. So over here, I've got my rough work. So here's my function. And then here is the function with x plus h subbed into it. So we can see it's cutting off. There should be a 1 on the end there. It's quite a long expression because I had to FOIL out this x plus h here and then expand out this x plus h, and nothing really canceled each other out. So I took that expression and I replaced our f at x plus h here with the expression. And then I'm going to subtract f at x, so this expression right here. And then when I simplify it by subtracting those two polynomials, I end up with the limit as h approaches 0 of negative 4xh minus 2h squared plus 3h over h. And again, I want to be able to sub in h equals 0. I still can't do that because I still have this h on the bottom. However, if we look at the top, there's h's in each one of these terms left on the top. So what I can do is I can factor out that h. That leaves me with negative 4x minus 2h plus 3 on the top. And then I can cancel out the h that I factored out with the h on the bottom. So I get the limit as h approaches 0 of negative 4x minus 2h plus 3. At this point, I can now safely sub in h equals 0. This term right here is going to disappear, and I'm left with my negative 4x plus 3 as the equation of the slope of any point that I can use to find the slope of any point on the curve at a specific value. Okay, so now that I have the equation to find my slope, what I want to do is I want to find the tangent line and the normal line at the specific point x equals 3. So in order to find the tangent line, I know I need to know two things. I need to know what the slope is and what the y-intercept is. So to do that, I'm going to start off by taking my function and I'm going to sub in x equals 3. So I'm going to find f at 3. And when I do that, I get negative 8. So I know that the point 3, negative 8 is a point on the function. And then at this point, I can use two strategies. I can either use sub it into y equals mx plus b to figure out what my b is. And then, or I could use my slope point form. So if I take my slope formula, m equals negative 4x plus 3, and I sub in my x equals 3, my slope is negative 9. And then from there, if I sub in my point and my slope, I get y equals mx plus b, which turns into negative 8 equals negative 9 times 3 plus b, and I get my b to equal 19. So I know that my slope is negative 9, my b, my y-intercept is going to be 19. So the equation of my tangent line is y equals negative 9x plus 19. So now on to the normal line. And a little bit of our work's already done for us because we know that the normal line is going to have a slope that is the negative reciprocal of the slope of my tangent line. So if the slope of my tangent line is negative 9, then the slope of my normal line is going to be 1 over 9. So instead of being negative, it's going to be positive. Instead of being 9 over 1, it's going to be 1 over 9. So my slope is going to be 1 over 9. So from there, I'm still using that same point, 3, negative 8. I'm going to sub in my point and my slope into y equals mx plus b. So I get negative 8 equals 1 over 9 times 3 plus b. And when I work that out, I get my y-intercept b to equal negative 25 over 3. So just to summarize, my slope of my normal line is going to be the negative reciprocal of my tangent line, which is 1 over 9. And that, when I do the new calculation, ends up giving me a y-intercept of negative 25 over 3. So my normal line is going to be y equals 1 over 9x minus 25 over 3. And I put this into Desmos just so that you can visualize what we actually found here. So here we have a picture of the function. So in the red parabola here is our function f at x. And I marked on here the point 3, negative 8. So that's the point that we calculated. And from there, I plotted on, first of all, our tangent line. So y equals negative 9x plus 14. So you can see how that tangent line just skims that point at 3, negative 8, and also has the same slope as the function would if we looked at the slope just at x equals 3. And then I also plotted on the line y equals 1 over 9x minus 25 over 3, which was our normal line. And you can see that that makes a 90-degree angle with our tangent line at that point, x equals 3. Okay, so what I would like you to do now is to pull out your survival guides, find the sheet that is titled Equations of Tangents and Normals, and I'd like you to take a few minutes to fill in your survival guide for this. So first of all, just making sure that you have defined what a tangent line is and what a normal line is. So this is kind of what I would write here. And I would also make sure that I put on there that just to remind myself that the slopes are going to be negative reciprocals of each other. In order to find the equation of a tangent or a normal, you must know two things. So you must know the slope, or you must know a point or the y-intercept. And you can use either y equals mx plus b form or point slope form, so y minus y1 equals m times x minus x1 to find the equation of your tangent. So using that information, what I would like you to do is pick an example or two, take a minute to work them out, maybe even from your homework questions, and then summarize those calculations right here so that you can look back on this and remember how you found the equation of tangents and normal lines. There we go, and that's it for now.